welcome to the second video for section 1. Our topic for this video is arc length, and by arc length I mean what is the distance or the length on this part of the circumference of the circle. And our first 2 points here, we're just going to simply try to find a formula whether our angle measure right here is in radians or in degrees. And especially for degrees, it's something that you've covered in geometry before. But we're just going to review and kind of show you why radian measure is so nice here. So first thing we should realize is that arc length is simply a part of circumference. So any formula that we come up with has to start based on circumference. And hopefully we realize that our circumference formula is 2 times pi times the radius. So 2 pi r. But if we look at my picture here, I don't want the entire circumference, I just want part of it. And so I'm basing that on this angle measure here. And so what I want you to think about for any sort of arc length formula is simply finding a fraction of our circumference. So if we have the entire thing right here, 2 pi r, I just want theta of that. And I need to think of what theta is out of. So if we're in radian measure, our entire circle is 2 pi, and I just want to have theta amount of that. So I'm going to take this entire part here and just multiply by that fraction, theta over 2 pi. That's going to give me the fraction or the part of this circle, of the circumference of the circle that I want. And hopefully you can see right away that some things are going to cancel out kind of nicely. We have 2 pi's in both the numerator and denominator. This will cancel out with that. And so in the end, our simplified formula in radians is simply theta times r. That's a pretty simple thing to remember. So that's one reason why we like it so much, is that radian measure gives us a very easy way of thinking through this. Okay, moving on to the second point, arc length is just a little bit more complicated. Let me move my screen just so I'm ready to write. If we're in degree measure, my fraction is a little bit different. It's still got the same setup, so I still want to think about 2 pi r. Is not what I wanted to do. There we go. Okay, so I still want to think about 2 pi r. Still want to think about the entire circle, but I'm just taking part of it, and again, it's based on theta. So now in degrees, an entire circle is 360. I just want theta of that. So I'm going to multiply this by the fraction theta over 360. Okay, so not as nice when it comes to simplifying. I'm going to have a lot of parts here. Really, the only thing that I can simplify is the 2 in the numerator and the 360 in the denominator. They will simplify a bit. And I'm going to be left with theta. Of course, this would pop up. We'll just wait a second. Dun, 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 dun. There we go. Okay, we will be left with theta in the numerator and a pi and an r in the numerator. And the 2 over 360 will just reduce to a 180 in the denominator. That's as simple as we can make it. So that's one reason why we really like radian measure. It makes it much, much easier to connect distances, or to talk about distances. This is a much easier, let me get my highlighter here, this is a much easier thing to work with than the formula down here. So just kind of keep that in mind. I know that this form, or the idea of radians, is still quite new to us, but there's a lot of reasons why this might be an easier method to use. Okay, so let's look at a couple applications. First of all, find the arc length of a 60-degree section of an 8-inch radius circle. So, because we're in degrees, we're going to use our degree formula. I would start by maybe just writing that down. So we would have a theta pi r over 180. That's going to be arc length. A lot of times, let me scoot this over here. A lot of times they say S for arc length. We just need to fill in the info then. So our angle measure was 60. We still have a pi there. Our radius was 8. It's going to be over 180. And it's just a matter of kind of plugging and chugging and making sure that we understand what some of the numbers are. I look at this and right away I see 60 over 180. That's going to simplify to 1/3. So I have a pi times an 8 over 3. At that point I want to plug that into my calculator. The pi and the 3 are going to sort of cancel each other out. So my answer should be right around 8 when I'm done with this. And I end up with 8.378. 8.378. And that would be in inches based on this problem there. Okay, so that's not a terribly tough application problem, but you still need to have a good understanding of the formula to do it well. Okay, next one, last one for this video. Let's assume that the running lanes at Emory Sears Track at Bluffton College are 1 meter wide. The inside radius of lane 1 is 33 meters, and the inside radius of lane 2 is 34 meters. We want to figure out how much longer is lane 2 than lane 1. And there is a picture of this on page 323. I included it right here. I don't believe that is in your notes, so you might want to copy down the picture first. So for this one, realize that we're at a half a turn. That would be 180 degrees in degree mode. We're going to do this in radians, so that is pi radians. And we're just going to first start with maybe a quick review of our formula. Our arc length for radian mode is simply theta times the radius. So for the inside track, I would have, let's see, inside track. Maybe we'll do lane 1. That's probably a better way of describing this. Let's see, undo. Okay, lane 1. That's going to be our angle measure, which was pi, right? Half a turn, 180 degrees, times the radius, which was 33. And for lane 2, be pi times 34. Now, I want you to think about how you would figure out how much longer lane 2 is compared to lane 1. You would simply subtract lane 1 from lane 2. So you would take 33 pi, write that out here a second, 33 pi, and you take that away from 34 pi. So I kind of have these written upside down here, but really what we're trying to do is take 34 pi minus 33 pi. So you need to think about how you would subtract that. The pi is kind of like our variable right now. I have 34 apples. I'm going to take 33 apples away. I'm left with 1 apple in the end. So in the end, my answer is going to be just simply pi, which we all know is about 3.14, and that would be in, let's see, meters. That would be our answer. Okay, jot down any questions you might have, and we will see you in class.